Hi, everyone. This is episode 3 in my little mini series, Fundamental Trig Identities. So, in the first episode, I went over just what are the identities, and then we kind of checked them on Desmos to prove that they are an identity, and we talked about the importance of having them memorized. In the second episode, we went over factoring specifically with a greatest common factor. In this video, we're going to continue that topic of factoring, but it's not just going to be greatest common factors anymore. So, again, when we're thinking about factoring, we have been factoring since, I don't know, some of us 8th grade, all of us at least by 9th grade, we have been factoring. And factoring comes in a lot of different shapes and sizes and forms, and there's a lot of different ways to factor. But the thing that you need to know about factoring is the word factor means things being multiplied together. So you're done factoring when you've got things that are being multiplied together. So what do we do when we're trying to factor something that has 3 terms? So for example, what if I gave you 4x squared plus x minus 3? If I asked you to factor this, I hope that everyone first looks for a greatest common factor. But when we look at this, our greatest common factor is 1, so that doesn't help us. After we look for that greatest common factor, then we need to ask ourselves, okay, I know that factor means that I need to break it into things that are being multiplied together. Right now, they're being added and subtracted. When things are being added and subtracted, that breaks things into different terms. This question has 3 terms because there are 3 different pieces of this function, this polynomial, that are being added or subtracted together. Right now, we don't have any factors because factors are when they're being multiplied together. So this is in standard form, and we want to figure out how can we get this into factored form. You have learned a lot of different ways to do this. You have learned how to do it by guess and check. You have learned how to do it by factor by grouping. You have learned how to do it by the Xbox method or the area model. And you have even learned how to just plug it straight into a graph and find your zeros and reverse your zeros. Because really the purpose of factoring is to find our zeros. So you can choose how you factor this depending on what you're most comfortable with. I personally am most comfortable with guess and check and factor by grouping. I guess and check when I have a prime number right here. I don't have a prime number right there. I'm not going to guess and check for this one. If guess and check is not the option that I choose, I almost always choose factor by grouping. So remember, it's factored when there are not single terms anymore. They're factors. They're being multiplied together. So in order to factor, I need to keep my expression equivalent all the way through. The first step of factor by grouping is to multiply this dude and that dude. Because end game, you're going to have something like that. 2 things that are being multiplied together to create these factors. So the first thing I'm going to do is I'm going to multiply this and this together because it's going to help me find my middle terms. I'm going to get negative 12. I need to find the factors of negative 12 that add to positive 1. So my factors of negative 12 are obviously 1 and 12, 2 and 6, 3 and 4, and that's it. Now, because it's negative 12, and because my middle term is positive, the smaller number needs to be negative. So it's going to be negative 1, negative 2, negative 3. Which of these adds up to positive 1? Well, that adds to positive 11. That adds to positive 4. There's our positive 1. What we are going to do is we're just going to split our middle term. Because when you're trying to group, you have to have an even amount of terms so that you can group them. So the 4x squared follows us down. The negative 3 follows us down. But we split our middle term with a negative 3x and a 4x. And it does not matter what order you put those in. I probably should have flipped them. I probably should have flipped them because then the 4s would be together and the 3s would be together, but whatever. It's no big deal. It's going to work. Now, as you're moving along, You want to make sure that your expressions are equivalent. So if you look right here, we have 4x squared plus x minus 3. Is this the same as this? The way that you figure that out is you just combine your like terms. If I combined my like terms here, I'd get a positive x. It is equivalent. Our next step in factor by grouping is to group our first set and our second set together and then play matchmaker. What do they have in common? What's our greatest common factor? So right here, our greatest common factor is an x. So I pull an x out front, which is going to leave me with 4x minus 3. If I distribute that x back in, I would get 4x squared minus 3x. I do the same thing here, but the greatest common factor there is 1. I don't normally pull a 1 out, but in this case, we're going to. Now, this is not factored form yet. It kind of looks like it might be factored form because like these are being multiplied and these are being multiplied. But if you still have a plus or a minus in between, it's not factored yet. So we're going to play matchmaker one more time. We've got this term and we have this term. What do they have in common? The stuff that they have in common, this and this, is what becomes one of your two factors. The stuff that they don't have in common, this and this, that becomes your other factor, like that. And there's our factored form. Now, again, if you don't like factor by grouping or if all of the stuff that I just said doesn't make any sense, then go to one of the other methods that you learned. You learned how to factor using the Xbox method. You learned how to factor using guess and check. And you even learned how to just take the zeros from a graph and reverse them. I know you've learned all of those because you had me as your teacher and I taught them all to you. So pick the one that you like best. Now, that's not why we're here for this video though. We're here for this video to figure out how do I factor when I have trig functions involved. So let's say I wanted you to factor this, 4 times sine squared of x plus sine squared of, not sine squared, just sine of x minus 3. Does that look familiar? I hope it looks familiar. Look, those are essentially the same thing. The only thing that has been changed, the only thing that's different is I've thrown in a few extra letters there. Instead of having an x squared, we have a sine squared. Instead of having an x, we have a sine. Everything else is the same. It is still binomial. It still looks like a quadratic. What you can do is you could take a little side journey and say, you know what? I'm just more comfortable factoring this. And you can factor that, which we already did. And then what you can do after you've factored it is take whatever function you've pulled out and replace the x's with that. So in this case, we had 4x. Instead of 4x, we're going to have 4 sine of x minus 3. So that came from this piece times sine of x plus 1. That right there would be your factored form. Now, if you're concerned, I don't know if I factored that right. How do I check? How do I make sure everything is right in the world? Then what you do is you take Desmos, you plug in your original equation like this. And then you plug in your factory equation like this. Do those equations line up? If your equations line up, you have factored it correctly. So if you're working on trying to factor an equation that has, it's not just a greatest common factor one, go back to one of those methods that you learned through simple algebra to factor. Then just replace the sine, the cosine, the tangent, the cosecant, the cotangent, whatever it is, just replace it in the end. Okay, I hope that video helped you see how to factor. In our next video, we're going to apply factoring with trig identities.